Alright, so we're going to start today with a Bellwork that kind of showcases what we learned yesterday or the day before. So in this lesson here, we do have a quadratic and it is in vertex form. So we can see there's parentheses here. So if we have a positive 2, we are going to be shifting in a certain way. And we have a positive 1 on the outside. So last time we learned is that inside the parentheses, when there's a positive sign, it's shifting left. So this is going left 2. And then the positive 1, if it's a positive on the outside, it's going up 1. So I'm going to go left 2, which would give me here, up 1 would be right here. And when I plot this, this is going to be my vertex. So my vertex is at negative 2, positive 1. So when it's in vertex form, meaning it's in the parentheses format, you can easily find the vertex by figuring out your shifts. Alright, we also learned the axis of symmetry is where the parabola cuts in half, and it always cuts in half in the vertex, through the vertex. So I'm going to draw my axis of symmetry through the vertex, and it hits it at x equals negative 2, so that's the equation of the axis of symmetry. It's at x equals negative 2, so you always write an x along with the number that it hits on the x-axis. Alright, the next thing here is we need more points. So to get more points, you want to use the slope. And this one's kind of strange because this slope here is negative 2 over 3. And one of the things I mentioned is that when you use the slope here, you always want to make sure that the run is 1. So what we're going to do to make this run 1 is to change this fraction to a decimal. If I change this to a decimal, this would be negative 0.66. And then when you change it to a decimal, you can put it over 1. So that's how you can force a slope to be, to have a run as 1, is to change the fraction to a decimal and then put it over 1. So this is saying down 0.66 because it is a negative. So I'm going to go down about 0.66, which is about like here, and then over 1, so to the right. So that would be like right here, and then I'm going to plot and connect the dots. And then I would reflect the other point, plot, and then connect the dots. So when I reflect the point, I'm basically also going down 0.66, but now I'm going to the left, the opposite direction. And then you just connect the dots and make your parabola. So looking at this, notice how it does point to the left and right. So we said this yesterday, but the domain for every parabola is all real numbers. And the range, well, the highest y value here is at 1, positive 1, and the lowest y value, it's pointing down, so it's negative infinity. So this goes from negative infinity to positive 1, and we put a bracket on the 1 because it actually can touch it at y equals 1, so there's a solid dot there for the vertex, so we can use a bracket. Alright, so pretty much in this lesson here, remember your shifts. If it's a positive sign, you're going left. Negative sign, you're going right. If it's a positive outside, you're going up. Negative, you're going down. And then the slope, when you use it in vertex form, you can use the slope, but you got to make sure that that run is 1. So if it's a fraction, just change it to a decimal and then put it over 1. And then domain for every quadratic is all real numbers. Alright, I think we're ready for the new lesson for today. So I'm going to show you quadratics in a different format because this is not the only way you can write a quadratic. Actually, most quadratics are not written with parentheses. Most quadratics don't really have parentheses. They're just written as, normal equations with just terms. So this is what I mean. Most equations, you don't have like parentheses here. You just have, your x squared, maybe another x, maybe a constant. So if you see it in this format here, this is what we call standard form. And standard form is where you don't see the parentheses, but you still see that your highest power here for x is 2. And so to use standard form, to figure out the vertex, you have to use a formula. So the step 1 to figuring out the vertex is to find x. So you're going to find x, and to do that, you have to use this formula. And you take your b and you make it a negative. So you take your b value, whatever the b or the number in front of x is. So a, b, and c are just coefficients or numbers that will be in front of either the x or just a constant on its own. and then you put it over to a. So this here is a really important formula you need to know how to use. Step 2 is you plug x and find y. So to find y, you're going to take the x value that you find, plug it into the equation, and then that leads you to y. So finding the vertex in standard form is a little bit of a hassle because you have to go through this process of using the formula before you can get the vertex. But it's not too terrible, but it's not as easy as the vertex form. Here's the nice part about the vertex form, about standard form. So standard form, what's convenient is that you can find the y-intercept really fast. It's always your c, or your constant that hangs out here. So the y-intercept will always be c, and make sure you write the y-intercept as a coordinate. So this would be 0, c, because the c here will represent the y value that it hits on the y-axis. And then every y-intercept, the x is equal to 0. Okay, I think we're ready for some practice problems. So let's try to find some vertex and y-intercepts if I give you an equation. So in this equation here, I have x squared plus 10x plus 23. So the first thing I'm going to do is figure out what is my a. And a is the number in front of x squared, so it's 1. B here is 10. C here is 23. Now, like I said before, the nice part about when it's in standard form is that you can find the y-intercept really quickly because it's your c value. So my y-intercept is going to be at 23. It's going to hit the y-axis at 23, which would mean that this would be at 0, 23, since x is always 0 for y-intercepts, and in this case, y is the c value that's in the equation. All right, the vertex, we're going to figure out the vertex by finding x first and then y. So to figure out the vertex, remember you have to use that formula, the negative b over 2a. So b here is 10, but there's a negative sign in the formula, so carry that over. 2 over a, which is going to be 1 here. And so I plugged in my a, I plugged in my b. I'm going to work this out, but negative 2 divided by 2 times 1, if I work this out, just gives me negative 5. So my x here is negative 5 that I'll write in here. Now I just need to find my y. So like I said in the directions, all you have to do is take your x and plug it into your equation to find your y. So y is equal to negative 5 squared plus 10 times negative 5 plus 23. Negative 5 squared gives me 25 plus 10 times negative 5 is negative 50 plus 23 gives me, well, if I add up all these numbers, I get negative 2. So that would have been my y value, and so this here would have been my final answer. Let me move this down just a little bit. So my vertex here is at negative 5, negative 2, and my y-intercept is at 0, 23. All right, let's try out this one here. So this one has a x squared minus x plus 5, and I can tell that my a here is also a 1, my b here is going to be a negative 1, and my c here is going to be a 5. And so like I said before, your y-intercept is really easy to spot when it's in standard form. It's just your c value. So my y-intercept is at 0, 5, and my vertex here I'm going to have to go find. So let's go find that x value first using that formula previously. So I have b, negative b, but my b here is negative 1. So if I drop down a negative 1, there are 2 negatives here. And then the bottom here is going to be 2 times a, which is 1. So like I said, the top here is going to be 2 negative, so that makes a positive. So this is positive 1 over 2, or 1/2, which is 0.5. So I'm going to change it to a decimal to make it easier to graph if I had to. I guess I don't have to graph here, but you know, 0.5 or 1/2 is the same answer. All right, next I'm going to find the y value. So this is going to be plugging in 0.5, squaring it, minus 0.5 plus 5. So what I did was take that 0.5 for x, plugged it in for these x's. Now, if I take 0.5 and I square it, I get 0.25 minus 0.5 plus 5. And so if I add up all these numbers here, I get 4.75, and then that looks like it's my y value. So this is 4.75. Okay, so to find, vertex and y-intercept, fairly simple. It's just a formula for the vertex, and the y-intercept is always your constant. Now that we've had some practice here, let's actually do some graphing. So in this scenario here, we have x squared plus 8 plus 10. So the first thing I'm going to do is write out my a, b, and c so I can figure out what is my a, which is 1, my b here is 8, and my c here is 10. So my y-intercept, I immediately can see that it is going to be 0, 10, because my constant here is 10. So when I draw this on the graph, I have to extend my coordinate system to 10. And so there's my y-intercept. But that's not the vertex. Now, to find the vertex here, I'm going to need to use that formula. So this is going to be x equals negative b over 2a, which is negative 8 over 2a, which is 1. So negative 8 over 2 is negative 4. So my x here is going to be negative 4. My y, to find my y, I'm going to have to plug in my negative 4 in for the x's. So that's going to be like negative 4 squared plus 8 times negative 4 plus 10. Negative 4 squared is 16 plus 8 times negative 4 gives me negative 32 plus 10. If I add up all these numbers here, I get negative 6. So my y here is negative 6, which tells me that this goes to the left to negative 4, then down to negative 6. So the vertex is right here. So it's really low. And so if this is the vertex, right, this is going to extend all the way up to the y-intercept. Because in this case, I can connect those points because they're part of the parabola. But we also mentioned that, the axis of symmetry would go through the vertex. And the vertex here is at negative 4, 6. So it looks like my axis of symmetry hits it at x equals negative 4. Okay, so there's my vertex, there's my extra point. I'm going to reflect that point to the other side so I can get my third point. So what I want to look for is how many units is this point here away from the axis of symmetry? Well, that's 1, 2, 3, 4. 4 units away. So I have to go 4 units to the other side directly across from the y equals 10. So that would be maybe like right here. It's kind of hard to tell. And then I would plot and try to make that into a parabola. But there we have it. So I reflected the y-intercept instead of using the slope, because I don't have a slope here. So I reflected the y-intercept to get the other point. And we can see here the domain here, it is pointing right and left. So it's going to be all real numbers for the domain, because it's a parabola too. So the domains always are all real numbers for a parabola. And the range here, the lowest y value here is here at the minimum point, right? So that's going to be at negative 6. And the highest point, well, they have arrows towards the end, so it goes to infinity. So this is negative 6 to infinity with parentheses and a bracket on the negative 6. All right, let's try out one more together before we get to the exit ticket. All right. So in this one here, we have this equation. So the first thing I'm going to do before I start is always label this as A, B, and C so I can figure out what are my coefficients. So my A here is negative 2, my B is 4, my C is negative 5, and that C there is going to help me, oops, I don't know why this zoomed in so much, there we go. Our C here is going to tell me the y-intercept. So this is going to be hitting it at negative 5 on the y-axis, which I'm going to go ahead and plot that. And so that coordinate is 0, -5. And then the next thing I want to do is probably figure out the vertex. So my vertex is using that formula, -b, which is 4, over, let me write out the formula. It always makes me more comfortable when I write it out. So -b is going to be -4 over 2 times -2. So if I work this out, the top is -4, the bottom is -4. Well, if I divide, that's going to be a +1. So x here is +1. Now I just need to find the y. So y equals -2 times 1 squared plus 4 times 1 minus 5. So if I'm multiplying by 1 here, or squaring it, I'm just going to get 1. So 1 times -2, -2 plus 4 minus 5. If I add this all together, I get, let me pause for 2, -3. So y here is -3. Okay, so to plot this vertex here, I would have to go over 1, down 3, and plot. So here's my vertex. So my vertex is going to also help me find the axis of symmetry, because I like to mirror the point once I find the y-intercept. So because this is the vertex, it's going to swing on down, and then if I mirror this point here, this is 1 unit away from the axis of symmetry, so I'd have to go 1 unit away from the axis of symmetry on the opposite side. And then we can connect the dots. And then we have our parabola. So it looks like our axis of symmetry is at x equals +1 because it hits it at 1 on the x-axis. Our domain is all real numbers because it's a parabola, so it's going to be always all real numbers. The range here is going to be, the highest y value here is at this point, the vertex, which is at -3. So that's the highest point. And the lowest point, it's pointing down, so it's going to -infinity. So it goes from -infinity to -3 as the highest point. And that's pretty much it. So I'd like you to try out the exit problem that is in the next slide. You're going to be doing a problem just like this, so make sure you label your A, B, and C. And find your y-intercept first, because that's easiest. And then see if you can find the vertex and draw the graph. Make sure it has at least 3 points. Alright, and here is the exit ticket. So see if you can figure out what the vertex, y-intercept, axis of symmetry, domain, and range, and then draw the graph for this equation. Until next time, guys. See ya!